Welcome to Math Tutorials. In this video, we are solving every question of exercise 12.1 from Chapter 12, Linear Programming, in the NCERT Mathematics textbook for Class 12, Part 2. Exercise 12.1 has 10 linear programming problems, all solved graphically by the corner point method. Maximizations, minimizations, optima along whole segments, and 2 cases where no optimum exists. Here is the list. Question 1 of exercise 12.1. Our first graphical maximization. One line plus the axes bound a triangle. The feasible region is the triangle with corner, points the origin, 4, 0, and 0, 4. Z at the corners, 0, 12, and 16. The maximum is 16 at 0, 4. Question 2. A minimization with 2 slanted constraints. Their intersection is one of the corners. Subtracting the boundary equations, 2x equals 4, so they cross at 2, 3. The corners are the origin, 4, 0, 2, 3, and 0, 4. Z runs 0, minus 12, 6, 16 over the corners. The minimum is minus 12 at 4, 0. Question 3. The corner is a fraction this time. Eliminate y between the 2 boundaries, multiplying the first boundary by 2 and the second by 5, and subtracting 19x equals 20. The lines meet at 20 over 19, 45 over 19. The corners are the origin, 2, 0, that crossing, and 0, 3, giving z values 0, 10, 235 over 19, and 9. The maximum is 235 over 19. Question 4. Greater than constraints, an unbounded region. The corner point values still decide. After an unboundedness check, the boundaries cross where subtracting gives 2y equals 1, at 3 halves, 1 half. The corners are 3, 0, that point, and 0, 2. Z is 9, 7, and 10 there. The region is unbounded, but the half-plane where 3x plus 5y is below 7 shares no point with it, so the minimum 7 stands. Question 5. Back to a bounded region. Find where the 2 boundary lines meet. From the second boundary, y is 15 minus 3x. Substituting, minus 5x equals minus 20, so they meet at 4, 3. Corners, origin 5, 0, 4, 3, 0, 5, with z values 0, 15, 18, 10. The maximum is 18 at 4, 3. Question 6. A minimum spread along a whole edge. Watch the objective match a constraint boundary. The boundaries meet at 0, 3, and the region's corners are 6, 0, and 0, 3. Z is 6 at both. Since z equals x plus 2y is constant, 6, on the entire boundary segment x plus 2y equals 6 joining them, the minimum occurs at every point of that segment. Question 7. Both optima requested. 3 slanted constraints give 4 corners. X equal 2y crosses x plus y equals 60 at 40, 20, and crosses x plus 2y equal 120 at 60, 30. The corners are 60, 0, 120, 0, 60, 30, and 40, 20. Z takes the values 300, 600, 600, and 400. The minimum is 300 at 60, 0. The maximum 600 is attained at 2 corners, so it holds on the whole segment joining 120, 0 and 60, 30. Question 8. Another double optimization. Y at least 2x squeezes the region against the y-axis. Y equal 2x meets x plus 2y equal 100 at 20, 40, and meets 2x plus y equal 200 at 50, 100. The corners are 0, 50, 20, 40, 50, 100, and 0, 200. Z is 100, 100, 250, and 400. The minimum 100 holds along the whole segment from 0, 50 to 20, 40, and the maximum is 400 at 0, 200. Question 9. An unbounded region with no ceiling. The corner values are only half the story here. The corners are 3, 2, 4, 1, and 6, 0, where z is 1, -2, and -6. But the region is unbounded, and the half-plane where -x plus 2y exceeds 1 does meet it, so z grows without bound. There is no maximum. Question 10, the last of the chapter. Contradictory constraints. Read the two inequalities together. The first demands y at least x plus 1, the second demands y at most x. No point satisfies both, so the feasible region is empty and z has no maximum. That completes exercise 12.1 and with it chapter 12, linear programming. In the next video, we begin chapter 13, probability. Thank you for watching. If this helped, do like the video, subscribe to the channel, and share it with your classmates.